Name of God. Hello, students. My name is Masoud. I'm a physics teacher. We are at your service in Fairkhaw's website to explain physics curriculum grade 10. So far, we talked about two sections from chapter 1. Right now, I'm gonna explain new section 1.3, the language of physics. Actually, we want to talk about language of physics. Any creature has its own language for communication, and the language of physics is mathematics. Language of physics is mathematics, right? For example, you want to explain any rule in physics. It needs a lot of explanation, but by means of one simple equation, you can, let's say, you can you can give your idea to the others. For example, think about the second law of Newton. It talks about force and mass and acceleration. You can write an equation for this law mathematically. That's why mathematics is the language of physics, right? Let's dive in with this lecture. Let me. So we have. Right now, we want to talk about the first. We have a question here. Question number 1. Define mathematical equation, right? And the title is mathematical equation versus physical equations. Actually, equation in general means relationship between variables and numbers in general. In mathematics, equation means relationship between a variable and numbers, right? But this equation is different from physics, actually. In physics, the equation means actually relationship between. Sometimes it's the relationship between only physical quantities without any fixed numbers, right? Let me write an equation for you. And the first equation for example, the equation for Newton's second law, F is equal to ma. What's this? This is physical equation. F stands for force, mass for m for mass, and a for acceleration. So this equation talks about the relationship between physical quantities. Do you observe any number here? So there is no number here. What does it mean? So physical equations are different from mathematical equations. Let me write a mathematical equation for you, and I want you to compare between these equations, right? I write y is equal to 2x plus, for example, 5, right? 2x plus. What are x and y, right? They are variables. What are 2 and 5? They are fixed numbers. So it's the relationship between variables and fixed numbers. This is mathematical equation. This is in math, right? But F is equal to ma. This is the second law of Newton. I told you force and mass and acceleration, they are physical quantities. So this is a physical equation. We have it in physics, right? They are different. By this introduction, let's dive in with the lesson with reading the question. Question number 1, define mathematical equation. It says, this is the answer actually, it's the relationship between variables and numbers, like this equation. Question number 2, define physical equation. It's the relationship between physical quantities, like this, F is equal to ma, right? And we have a note here. I told you actually at the beginning of my lecture, I told you mathematics is the language of physics. So we explain our idea by means of numbers, by means of equations. That's why, let's say, physics has its own language, and its language is mathematics. And you know who entered mathematics to the physics actually in 17th century? Galileo entered the mathematics to the physics, and physics, I can say, uh, in action separated from philosophy, right? Uh, let's talk about other. Let me read. Uh, so we have another subject here, dimensional analysis. What's the meaning of dimensional analysis? In some situations, we need to have some equations, right? For example, let me give you an example. We want to travel from a city to city, right? So we want to travel a distance. I say we want to travel a distance. Keep in mind that distance is a physical quantity, right? So our car, for example, uh, has a particular velocity. I say velocity. So I mentioned two things: distance traveled by the car between two cities, and velocity for the car, distance and velocity. So we want to look for a time interval. How long does it take the car to travel, let's say, this distance? We have two information. By this information, I can, let's say, we can find the time interval required for car to travel this distance, right? Uh, so, for example, think about this situation. We have no any rule. For example, I I don't have any rule for this. Let's say for finding the time interval, but let me explain it for you mathematically. I told you about the distance. So we have distance in meters, right? Distance is measured in meters. We have velocity measured in, let me change the unit, right? Distance measured in kilometers. Let me write it. Let me erase it for you. So distance is measured in, for example, kilometers, because the distance between two cities is measured in kilometers, not in meters. That's why I changed it. Velocity is measured in kilometers per hour, right? So what do we look for? We look for delta t, time interval, right? So how do I find the time interval? I look for a rule for finding time interval, right? I say if I multiply, for example, d distance by velocity, I can find delta t. This is my first, for example, solution, my first trial. Let's do it together. I say kilometer multiplied by kilometers per hour, right? Whenever you multiply them together, what do you get? You get, for example, this equation, this, let's say, fraction, kilometers square over hour. Is kilometers square over hour is the unit of time? Of course not, yeah? So this, let's say, this trial is failed. I have to look for another trial. So the first trial, multiplication between distance and velocity, was failed. I look for another solution, right? For example, I say when I divide velocity by, let's say, distance, by this approach we can find the rule for, let's say, time interval. V is measured in kilometers, right? Divided by a distance, velocity is measured in kilometer per hour, divided by what? Divided by kilometer, because kilometer is the unit for the distance, right? I want you to, let's say, divide these fractions together by one another. So what do you get? Let me write the, let's say, answer here. Can I say kilometer cancel with kilometer? These, let's say, parts, the numerator of the first fraction, right, multiplied by the denominator of the second fraction, goes to the numerator. So we have 1 here, right, divided by h goes down. So is 1 over h is the unit of time interval? Of course not. So in the second trial, we failed as well. But we are very close to the answer. We are about to, let's say, to find the rule. If you flip the fraction, what do I mean by flip the fraction? I mean, whenever you divide distance by velocity, you get what? You get h over 1. And h over 1 means hour. So this is called dimensional analysis, right? Whenever you, let's say, take a look at this approach as actually, you see that we deal only with units. We didn't deal with numbers. So dimensional analysis means dealing with dimensions, dealing with units only, neglecting the numbers. This is called dimensional analysis. So we deal with variables, or we deal with, for example, symbols. We deal with dimensions. We deal with units in order to what? What do we search for? Actually, we search for some simple rules. This is called dimensional analysis. So what's the dimensional analysis? Dimensional analysis means using the units, right? Dealing with units for finding simple, very simple rules and check their validities. And dimensional analysis is not only used for finding the, for example, rule. We can use it for checking the rule, whether the rule is right or wrong, right? Let me read let's read the definition for you. It says, this is the definition actually, using the dimensions to build a simple physical equation or check its validity. What's this? This is dimensional analysis. We have a question here. What's the question? This third question actually. The number is the complement of the other previous questions. Suggest an equation for acceleration measured in meter per second square in terms of both force and mass, measured in kilogram meter per second square and kilogram respectively. So what do we look for? Let me tell you something. Let me tell you the secret actually. What's the secret? It says suggest an equation for what? For acceleration. Let me underline acceleration for you. When I underline it actually, acceleration, we look for a rule for acceleration. So I have to write A is equal to, I have to start with this quantity because it says suggest an equation for acceleration. I should write A is equal to, I told you, like the previous example that I told you, actually. So here, in your opinion, actually, don't look at the answer actually. Let me try a wrong, let's say, trial. I want to try a wrong trial. I know the answer, but I want to, let's say, explain it for you. For example, I say acceleration is found by what? It's found by multiplication of force and mass. This is my suggestion, right? So I wanted to substitute the unit, let's say, for each let's say, quantity, actually based on the information within the question, right? So acceleration is measured in meter per second square in the question, right? So right now, there is no longer acceleration right now. I changed it to what? I changed it to the unit. So acceleration replaced by what? Acceleration is replaced by meter per second square. Force is replaced by what? Force is replaced by its unit. I mean kilogram meter per second square. Multiplied by what? Mass is measured in kilogram, right? If the after calculation, if the left part and right part, let's say, are equal, if they balance one another, so your suggestion, your equation is right. But if they don't match, actually, the equation is not valid. You have to think about another equation. You have to look for another, for example, trial. Let me write it here. So I say meter per second square. I bring it down. Meter per second square is equal to here. A kilogram times kilogram becomes kilogram square, right? Multiplied by meter divided by second square. So can I say the left part balances right part? Can I say the left part is equal to right part? Of course not, yeah. They are completely two different, let's say, units. So in this situation, the equation is not valid. Why? Because the left part does not coincide with the right part. My trial is wrong. So I have to look for another trial. This is the let's say correct trial. For example, after you failed in the first, let's say in the first, for example, rule, you have to write another rule. You have to think about, for example, we have to think about division, because we tried multiplication and we didn't, let's say, get anything. Right now, A is equal to, this is the, for example, solution of a student. A is equal to F over M, right? Write the unit for acceleration. Actually, based on the question, acceleration is measured in meter per second square. Bring it down. Right now, there is no, we don't have acceleration anymore. Instead of acceleration, I write meter per second square. Instead of force, I write the unit, kilogram meter per second square. And instead of mass, I have to write its unit, which is kilogram. I can cancel kilogram with kilogram. The left part, meter per second square, I write it as it is. And the right part, right now we have meter per second square. So left part balances right part. That's why this equation is valid. Dimensions are consistent, right? This equation is valid. So we found the rule for finding acceleration by means of dimensional analysis. This technique is called dimensional analysis. Let's move on to another question. Check the dimensional consistency, right? For the equation D is equal to V over T, where D is the distance measured in meters, V is velocity measured in meter per second, and T is the time measured in second, right? Firstly, it gives, in this equation, it's the opposite case of the first one. In the previous equation, it gave us, for example, it wanted us to suggest a rule. There was not rule, but right now it gave us a rule, and we want to check its validity, whether it's right or wrong. So this is our equation. D is equal to V over T. It gave it us actually. D is equal to V over T. Let's say the question gave it, let's say, to us. Instead of distance, so distance is measured in meters. Maybe you say, teacher, why don't you write centimeter? But here you have to obey the information inside the question. You are not allowed to write any equation, any unit instead of the quantity. You have to obey the information within the question. Because here it says distance is measured in meters. You are not free to choose any other units, right? So instead of D, I have to write meters. Instead of V, I write meter per second divided by time. Time interval is measured in second. So right now, I want you to put let me put a denominator of, let me put a denominator of 1 for this fraction, s over 1. And mathematically it's right, it's true. So far with far, far with far, near with near. Far multiplied by far, I mean meter multiplied by 1 goes to the numerator, and near with near, I mean s times s goes to the denominator. That's why the right side does not coincide with the right side does not coincide with the left side, so the equation is not valid. dimensional consistency. There's no dimensional consistency here. Dimensions are not consistent. So this rule is wrong. It's not accepted. So this is the solution actually. You have to write only here, only this part. So you check the rule by means of dimensional analysis. Have you ever noticed, let's say, any number? So there's no number here. Only we deal with symbols. We deal with let's say, units only. That's why we say dimensional analysis. We focus on dimensions. We focus on units, not numbers. Another question. We have another question. Question number 5. Check the dimensional consistency for. It says for, right? Let me draw. For the equation, we have an equation. Let me underline the equation. We have to check this equation whether it's right or wrong. V is equal to lambda f, where lambda, this is lambda, it's a Greek letter actually, is used for wavelength. Lambda is wavelength measured in meters. V speed of wave actually measured in meter per second, and F frequency of wave measured in 1 per second, right? Let's say do the calculation. We want to check this equation, right? Firstly, I told you, without any thinking, just substitute the unit instead of the variable. Substitute the unit instead of a quantity. Here, I have to write the equation. That's the first step of the solution. V is equal to lambda f. V is measured in meter per second based on the question's information, is equal to lambda is measured in meters, and frequency measured in meter per 1/second. Right now, the left part, actually, I write it as it is. What do you say about the right side? You have to multiply numerator with numerator, denominator with denominator. Actually, whenever you do this, you see that the left side and right side are, let's say, equivalent. They are equivalent. That's why the equation is valid. So we accept this rule. This rule is correct. Let me explain another subject. We have order of magnitude. What's the order of magnitude actually? Sometimes calculations are difficult actually. Doing calculations are difficult. And we don't need, for example, accuracy for some cases. We don't have accuracy. That's why let's say we concentrate on order of magnitude. We use order of magnitude. So what's the order of magnitude? Order of magnitude means, let's say, using powers of 10 nearest to the numerical value for the quantity. Let me give you an example. I say the length of, for example, the length of a, let's say, playground at a school actually. The length is approximately, for example, 92 meters. Yeah, 92 meters. So to avoid, let's say, this number, to avoid accuracy actually, we don't need accuracy here. You can say approximately the length of the playground is 100 meters or 10 to the power 2. So I say 10 to the power 2. I focus on power of 10 instead of, for example, saying the length of the playground at the school is 92 meters. Let's say, round it to 1. I round it to the nearest power of 10. And by the way, any number lies between two numbers, between two powers of 10. Any number, think about any number. This number is located between two powers of 10. For example, say 4. Think about 4. 4 is located between two powers of 10, but it's closest to the 1, and it's a little bit farther than the other. So instead of the, let's say, instead of the number itself, I round it to the nearest power of 10. Let me give you an example. I want to write let's say, an example for you, and after that, we discuss these questions together. We have, I said 4, yeah? This number 4 is located between two powers of 10. 4 is greater than, is less than. 4 is greater than 10 to the power what? Think about it. 4 is less than 10 to the power what? Right? So 4 is greater than 10 to the power 0. Because 10 to the power 0 means 1. Right? It's true. 4 is greater than 1. And is less than 10 to the power 1. It means 4 is located between 1, because this is equal to 1. 10 to the power 0 means 1. 4 is greater than 1, and it's, let's say, smaller than 10. But what's the order of magnitude actually for which power is taken for 4? Instead of 4, maybe you say, teacher, I use 10 to the power 0. Other students says, teacher, I use 10 to the power 1. So which one is correct? Actually, think about the nearest power of 10 to the numerical value. 10 to the power 0 means 1. Is 1, let's say, closest to 4 or 10? Here we have, between 1 and 4, we have only 3, let's say, integer numbers. But here between, let me write it here, 3 integer numbers. But here between 4 and 10, we have 6 integer numbers. That's why this power is closest to the power to the 4, right? So the order of magnitude of 4 becomes 10 to the power 0, not 10 to the power 1, right? Let me read the question for you. Read the definition and after that I discussed this question with you. It says order of magnitude. This is our title. The nearest power of 10, the nearest power of 10 value to the value of physical quantity. Nearest power of 10, like this example. Why didn't I choose 10 to the power 1? Because 10 to the power 1 is farther, let's say, than 10 to the power 0 to the 4. That's why we neglected. We only focused on 10 to the power 0 because it's nearer to 4 than 10 to the power 1. Right? Question number 6. Order of magnitude for 70-year-old person is 70, right? 70. So I told you 70 is located between two powers of 10. Think about it. 70, let me write it here. 70 is greater than, is less than. 70 is greater than 10 to the power 1. This is, let me write it. I say 70 is greater than 10 to the power 1, and it's less than 10 to the power 2. Right? It's located between, let's say, 10 to the power 1 and 10 to the power 2. This is, so in your opinion, is 70 closer to the 10 to the power 1 or 10 to the power 2? Of course, you say 10 to the power 2 because 10 to the power 2 means 100. 70 is closer to 100 than 10. That's why this is our answer. 10 to the power 2 is the order of magnitude of number 70. 10 to the power 0, it can't be because it's very far from 70. 10 to the power 1, I examined it for you. It doesn't, we don't count it actually. We don't use it. 10 to the power 0 is the best answer, right? Other question, what's the order of magnitude for mass of an elephant with 1,800 kilograms? 1,800 kilogram or 1,800 kilogram. So 1,800 kilogram is less than something and is greater than something. 1,800, think about it, is greater than 10 to the power what? And it's less than 10 to the power 1. So 1,800 is greater than 10 to the power, let's say, 1,000, yeah? 10 to the power 3, excuse me. 1,800 is greater than 10 to the power 3, means it's greater than 1,000. But it's less than what? It's less than 10 to the power 4, means it's less than 10,000. I'm sure you know the answer right now. So which power is nearer to 1,800? Is 10 to the power 3 near to the 1,800 or 10 to the power 4? 10 to the power 4 means 10,000. Actually, this number is closest, power of 10. So 10 to the power 3 becomes order of magnitude of, let's say, 1,800. This is the answer. The last, another question, it says, order of magnitude for 16-year-old student is 16. Let me write it here. 16 is greater than 10 to the power what? And is less than 10 to the power what? So 16 is greater than 10 to the power 1. It's greater than 10 to the power 1. Means, right? But it's less than 10 to the power 2. So which one is actually taken? Which one is convenient? Which power of 10 becomes order of magnitude for this number, for 16? Right? Of course, this number, because 10 is much, let's say, closer than 10 to the power 2 to the 16. This one, 10 to the power 1, becomes order of magnitude of number 16. Let's move on to another question. Question number 9, right? Let me solve this question. Solve the mathematical operations below. We have an equation. We have actually two operations. One, we have the first one, we have multiplication, and the second one, we have division. Right now, 1,124 multiplied by 57. We look for the answer. Actually, I told you, we don't need the exact number. Actually, we look for the power of. We focus on the power of 10. We deal with power of 10. I mean, we have to convert these numbers to the powers of 10, to the order of magnitude. Right now, let's do it together. 1,124. What's the order of magnitude of this number? Actually, 10 to the power 3, right? Multiply by 57. What's the order of magnitude of 57? Actually, 10 to the power 2, because 100 is closer to the 57 than 10 to the power 1. That's why instead of 57, I write 10 to the power 2. Right now, so we are about to finish. It's very easy, actually. We are close to the final answer. 10 to the power 3 times 10 to the power 2. Write one common, let's say, base, and add the exponents together. It becomes 10 to the power 5. Let's move on to another question. 649 divided by 20. 689. What's the order of magnitude of this number? Actually, 600 is more than 500. It's very close to the 1,000 than 100, actually, right? 649 actually is closest to the 10 to the power 3. So order of magnitude of this number becomes 10 to the power 3 divided by 20. Actually, 20 is close, actually very close to the 10 than 100. Compared to the 100, actually, 20 is very close to the 10 to the power 1. That's why order of magnitude of 20 becomes 10 to the power 1. So we have one more step here. Just divide the base and base together. Actually, we have a rule here. In the case of division, write only one common base. We have common base here. The common base is 10. Write one of them, and 3 minus 1. Subtract 1 from 3, and the answer will be 10 to the power 2. That's all for today. Thanks for watching this video. I want you to follow our videos in next lectures, and bye for now.